let's get started. Firstly, I'm going to explain a bit about what is WebTransport for people who aren't familiar. So it's a UDP-based protocol. It's built on top of HTTP3, and it supports unreliable datagrams, reliable and unreliable streams, unidirectional and bidirectional streams, server-initiated and client-initiated streams, flow control, and back pressure. It's session-oriented, so that means you create a session once, and then within a single session, you can create any number of streams. You can send however many datagrams you want. Creating a session requires a single round trip to the server, but once the session is created, stream creation can be done with no round trips. So it's very cheap. So you can create streams and throw them away at great speed, and it'd be a very pleasant way to work. So for security, we use the web origin model. So we send the origin to the server, so the page can't forge it, and servers make a decision whether or not to communicate based on that origin. This is a similar security model to WebSockets. Similar to WebSockets also, the user doesn't have to give explicit permission because it's designed to be safely used from any page. It obeys the content security policy, although we haven't actually standardized that part. And it applies congestion control, so it can't be used to do denial of service on routers or other middle boxes. It will behave as a well-behaved network citizen. So here's an example of creating a session. As you can see, you just use the WebTransport constructor, pass in a URL, and then wait until it says it's ready, and you're done. Sending datagrams is straightforward. We're using the Streams API, so if you're familiar with the Streams API, this will be particularly easy for you. But even if you're not familiar with the Streams API, it's pretty straightforward to see how to send datagrams. And receiving datagrams, it's also straightforward. You just use the read method and get a value is the actual contents of the datagram as a uint8 array. Done is a flag that says whether you're going to receive any more datagrams. So usually that will be false. To create a reliable stream, in this case, I'm showing creating a unidirectional stream on the client. You can also create unidirectional streams on the server, or create bidirectional streams either on the client or the server. So it's pretty straightforward. You just request to create a stream. This is an asynchronous operation because the server has the ability to limit the number of streams that can be created at the same time. So we may have to wait for the server to give us permission to create a stream before we can create one. So it's asynchronous, but usually it will complete without having to contact the server. So usually it will be extremely fast. Then we just get a writer on it as is normal for a writable stream. We write our message to it and we close it. The message can be extremely small. I mean, it's fine if the message is only a few hundred bytes because we can create streams very cheaply. Unreliable streams, basic idea is that we use a stream as normal, but then we prevent retransmission. However, we haven't fully decided how we want unreliable streams to work. So if anyone's interested in that question, it'll be good to discuss it afterwards. We need to gather use cases for unreliable streams and work out the what's the best API to do it. So this might not be the way that unreliable streams work, and in practice this reset method is not yet implemented in Chrome. So currently in Chrome, the only way to do unreliable streams is on the server side. So essentially on the server, if you decide you're not interested in the stream anymore, you could send a reset stream message from the server, which will cause the client to stop attempting to retransmit the stream. So that's the end of my brief introduction to WebTransport. If anyone has any questions so far, please raise your hand. Otherwise, I will continue with speaking about what we've changed and updated recently. Okay, so let me proceed. The quick transport protocol is gone. So the first thing we implemented in Chromium was the quick transport URL scheme. The protocol was built directly on Quick. However, we have changed the protocol and we're now building it on top of HTTP3, which provides a richer basis on which to base the protocol and may integrate better with HTTP3 servers. So instead of the quick transport URL scheme, we use HTTPS URL scheme now. But WebTransport's not the same as HTTP. It's not a request response protocol. It's a multiplexed bi-directional protocol. So you can't use the same URL for both WebTransport and HTTP. Well, technically you can, because the server can determine whether it's a request for WebTransport or a request for HTTP resource. But please don't do that because you'll confuse everybody. So the quick transport constructor is now gone. So previously, if you wanted a quick transport stream, you would say new quick transport and pass in a quick transport URL. That's now gone. We now use the web transport constructor. So the original idea was that we'd have a quick transport constructor and we'd have an HTTP3 transport constructor and maybe a fallback transport constructor for environments where quick would not work because UDP was not passed through, for example. However, now everything will go via the web transport constructor and we'll decide the protocol based on the URL scheme. Currently, we only have one protocol anyway, the HTTP3 based protocol. So that's pretty straightforward. So there have been numerous ergonomic improvements, of which this is just a minor selection. Originally, it was create send stream. However, that was just send stream is the name of the object that you are creating, but it's not very intuitive why it's called send stream. So now that's create unidirectional stream to make it clear that you're creating a unidirectional stream. Instead of the stream having a writable member that you have to access to get the writable, the stream itself now inherits from writable stream. However, that's not actually implemented in Blink yet, but we hope to have that implemented either in M92 or M93. So that will be done soon. But so for the time being, you still need to say stream.writable.getWriter in Blink. Last year, the spec was very vague. And so the implementation in Blink, we just made lots of stuff up that was not explicitly specified in the spec. The spec's now much more concrete, but that means that Blink doesn't actually match the spec in every detail anymore. So an example of where the spec is more concrete is that datagram queuing is now specified so that if a datagram in the queue is too old, it will be dropped rather than rather than leaving stale datagrams in the queue. But Blink's implementation has a queue of size 1, and it doesn't actually care how stale the datagrams are, so it would turn even stale datagrams. Bi-directional streams, according to the spec, they support half close, which means you can close the sending side and continue to read from the readable side. However, in Blink's implementation, closing the sending side actually closes the readable side at the same time. So that will have to be updated. So is the current status of WebTransport. In Blink, we have mostly compatible implementation behind the usual experimental web platform features flag. There's also a WebTransport feature flag if you want to turn only WebTransport on without turning on other experimental features. Origin trial starting in M91. In M92, we have compatibility improvements, in particular to the way the datagram accesses are accessed. And we're provisionally planning to ship this year. This is dependent on getting sufficient progress on standardization and in particular sufficient progress on web platform tests. JavaScript API standardization status. It's being standardized at the W3C. The standard is currently rapidly evolving, as in it's changing several times a week at the moment. And I expect we'll be in a state where other browsers can write interoperable implementations within a month or so. There's still things in the standard that are vague. So currently, if you're trying to implement it, you'd have to like check what Chromium does and align with what Chromium does. Since what Chromium does isn't necessarily right anyway, that wouldn't be a very good approach. But hopefully very soon it will be possible to write an implementation purely based on the standard and expect it to be interoperable. Protocol. So the older quick transport had multiple independent implementations. However, the IETF has made the decision not to continue with quick transport protocol and instead build the HTTP3 based web transport. And that has been formally adopted by the IETF Web Transport Working Group and is currently implemented in Chrome for our test purposes, but other implementations are in active development at the moment. So testing. We're going to test it in the web platform tests via a Python-based server. There's already some web platform tests. However, we're currently blocked on support for the latest HTTP3-based draft. So we can't test the protocol details yet. We are planning to fix that soon-ish, but we don't have an exact timeline for when that'll be ready. So we have actively engaged partners. Can't really tell you who they are, but there's a lot of interest in web transport, and so a lot is going on there. Right, so time for questions and discussion. So does anyone have any questions? Yes.
I will jump in with, so you mentioned denial of service. Is it, I might, sorry for overlooking the detail. The connection is only possible to be established with the origin that served the web page content, or?
Not completely. The server can allow connections from any origin. So the server may decide to only allow connections from its own origin or from some other origin that it either trusts, or it may decide to support any origin and take care of avoiding denial of service itself. So the server gets full options there to choose what it wants its permissions to be. I mean, in practice, even if you're only trusting your own origin, you're probably going to want some denial of service protection in your server because your JavaScript code may go haywire. So we're also going to limit the number of sessions, limit the rate at which sessions can be created, because otherwise you could denial of service the server just by constantly trying to create new sessions to it. And so we have to have some protection against that.
Okay. So maybe a related question is peer-to-peer possible at all?
Not currently. So what we do support at the moment is setting server fingerprints parameter on the constructor, which allows you to specify what certificates may be used to establish connections. So you're not necessarily dependent on public key infrastructure. The page can supply alternative certificates that can be considered valid. However, the interaction with the content security policy is not yet standardized. So obviously you can say, hey, I want to connect to google.com, but I want to use this certificate. That's not a real google.com certificate. Then you can connect to some other server that's claiming to be google.com. So if the content security policy said google.com was okay, but in actual fact you were connected to some other server, then you'd have bypassed the content security policy. So we need a fix for that. So the tentative plan at the moment is just to not allow that server certificate override thing to work when you have a content security policy. However, we don't have a concrete plan at the moment. However, that's something we will do before shipping.
So part of the nature of my peer-to-peer question is we've seen a variety of applications try to use the data channel on WebRTC for things like games, and they want to operate from a user agent to another user agent, and be as serverless as possible, hand waving regarding NAT and stun and all that. So I'm unsure if that's in the long-term goals of WebTransport or not.
So it's not currently in scope. We're currently focusing on either client to server or client to ephemeral, don't know how to pronounce that word, ephemeral server are our current targets. If we wanted to do peer-to-peer, we would want to make it simpler than the current WebRTC solutions. There was an implementation of quick transport for WebRTC. However, it's been removed from Chrome and it was never shipped. So that would have provided better performance than the existing SCTP based channels that WebRTC provides. But currently we don't have a good solution for peer-to-peer, unfortunately. But it is kind of on our radar.
Thanks.
So any other questions?
I forgot about unreliable streams until recently. So what's the good point about it compared to datagrams?
So what I see as the use case is if you're sending small messages, but you're not actually sure that the message will fit in a single datagram, then using an unreliable stream is a much easier option. obviously you can always use datagrams. Anything can be implemented on top of datagrams. It's a very flexible mechanism, but it's not necessarily the most easy mechanism because you have to take into account the MTU. There is, I think, an API in the standard to query what the MTU is, but it's not implemented in Blink. So currently you have to kind of guess what the MTU is, or attempt to determine the MTU yourself by usual MTU discovery type mechanisms, but in your JavaScript code. So basically using the datagrams is a low level, slightly difficult way to work. So if your messages are probably like a kilobyte, but some of them might be 2 or 3 kilobytes, then you don't really want to have to deal with the low level datagram API. You'd like to just be able to send your message. But if you want that guarantee of message freshness, in other words, you want to avoid retransmit because it would result in your message being arbitrarily late, then you're going to want unreliable streams. So that's my vision of the use case for unreliable streams. Other people may have other visions of what they want to be able to do with unreliable streams, and hopefully somebody here has an idea of what they'd like to do with unreliable streams, and will speak up. Okay, I'm taking that as a no. So yes. So yeah, the strength of unreliable streams is avoiding head of line blocking, although you still get head of line blocking within your stream. So if you're sending a very large stream, then possibly unreliable streams are not that useful. If you're sending multiple megabytes, probably it's not terribly useful to say I want to send multiple megabytes as unreliable, because what happens if a single packet drops in the middle of your multi-megabyte stream? Are you not going to retransmit that? Are you going to send the whole multi-megabyte thing again? It seems like that wouldn't work very well. So my vision of unreliable streams is they're useful for fairly small streams, but where you don't want to deal with having to fragment your stream into datagrams yourself, you just want something that works. Streams are unordered with respect to each other. So you can, even with reliable streams, you can create 2 streams in, like, you can create stream A and stream B, but then in the server, they might arrive with stream B before stream A. This might turn out to be a foot gun for some people, but it's also a benefit. One of the kind of selling points of WebTransport is that we avoid head of line blocking. So each stream is not blocked behind the other streams, even if they may have been started first. So if stream A is busy retransmitting, but stream B is able to go through without retransmits, then that means that stream B will arrive first. But we're assuming that that's because you want stream B first. Okay, so I expect people will want to get to their next room. Do we have any further questions or items for discussion? Okay, so right, I think we shall finish there. So thank you everyone for coming. I hope this was interesting to you, and that if you have a use case for WebTransport, you'll be thinking about adopting it soon. As I mentioned, the server situation is not ideal at the moment, but pretty soon we will have a better server situation where hopefully it'll be straightforward to integrate WebTransport into your application. So yes, as I say, thank you very much for coming, and that's the end.